Okay, let's take a look at section 3.3 and see if we can get you some guidance on this section. I will say that this is a long section and there are some challenging problems in here, so just be prepared to take some good notes. Hopefully you've already taken notes through the instructional videos and maybe this will help you a little bit more. So let's get started. All right, first of all, we've got to talk about a new term called a tautology. And a logical statement which is necessarily true is called a tautology. The main thing that you need to know about this is that if you do a truth table, your final column will be all truths. And so that is the main emphasis of a tautology. So let's take a look at an example that uses this. It says to determine whether the given compound statement is a tautology. And so we are going to do a truth table with this. And so here's how we've set up the truth table. We've set up the P's and Q's like we normally do. And then the first thing that I want to look at is I want to look at not P. Um, and that's because, in here you have P, Q, you have Q implies not P. So I know that I'm going to need this not P, so I'm going to go ahead and just set it up. So if you do that, not P would be false, false, true, true. Okay, so then the first thing we're going to look at is P or Q. And so if you just do P or Q like we've done before, you will get true, 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 and false. So then we need to look at Q implies not P. So now I'm going to look at these two columns. All right, so whenever you do, and remember this is an implies, okay? So when we talk about implies, it gives us a whole different truth table. So when we do this value, we will get false to begin with because you started out with true and you didn't follow up on your end of the bargain, so that means it's false. Um, and so you get false and then all truths. All right, then the last thing is that we're going to combine the next two columns together. And when we look at those two columns, they are going to be combined with an and. And so we're just going to take these values, true and false, true and true, true and true, and then false and true. So whenever we do, we get false, true, true, false. Now, the whole point of this truth table was to determine if this was a tautology. And remember that we said that a tautology says that you will end with all truths. So in this case, we did not end with all truths. So this is not a tautology. Okay, now let's look at another example. So here's another example. And this is called a biconditional statement. And basically, you have to prove that this first set implies the second, and then you have to turn around and you have to say that this second set implies the first set. And so that's what we're going to have to prove here. So let's set up our truth table. We set up our P's and Q's like we normally do. The first thing is that we're going to do P or Q. So we can do that, and you end up with true, 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 false. Now we're going to look at Q or P. And so you will end up with the same true, 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 false. Okay, now we've got to go in one direction. So we've got to show that this side implies this side. So if you'll see, I did that in yellow. And so we're going to show one direction. And basically that means we're going to look at this column implies this column. Okay, so when we do that, we end up with all truths. But we've got to go backwards now, and we've got to show that this column implies this column. Okay, so I know that's kind of confusing, but because we have this double-sided arrow, that's what that means. All right, so you end up, when you do that, you end up with all truths. So now you've actually got to prove one more thing, and we are going to take a look at this yellow column and join it to the green column with an and. Okay, so if we get all trues in this statement, then you would say that this is a tautology. Well, everything is true, so you would get all trues. So therefore, whenever you look at that, this would be a tautology. So you just kind of have to piece your truth tables together one column at a time. All right, let's take a look at another example. Okay, this is a very, very important table that you need to make sure. Let me see if I can get my picture off here. All right, you just need to make sure that you understand this table, okay? If I were you, I would write this down in some notes because you're going to use it in several different places. So, keeping a notes for this chapter, you should have all of the truth tables that we've already talked about in previous sections, and then add these truth tables to it as well. Okay, so let's look at a few examples of how we're going to use this table. Okay, so let's look at example 3. All right. So we want to say, we want to verify that the indicated definition from the additional operators table, and we're going to do this by using a truth table. So we are actually going to, oh, that's my daughter. Come here and say hello to everybody. This is Mama's doing a lesson. All right. See, there's your picture. See your picture right there? Okay, can you look right here at that dot? All right, go up so they can see your face a little. Okay. This is my daughter Lillian, and today is her birthday. So, Mama's having to do a little work on her birthday. All right, can you say hi to everybody? Say hey. Okay, thank you. Now, can you go to your room? Well, they're on. These are Mama's college students. Okay. Okay. I'll be right back. Okay. Sorry for that interruption. Um, let's take a look at how we're going to solve this example. So we are going to use that table that we just did, that we saw, but we want to actually use our truth table in this case. So we have P unless Q. All right. So it says according, so I gave you a little snip here of that P unless Q. It says that it is equivalent to not Q implies P. Okay, so this is what we should get in the truth table if we did not Q implies P. So let's see what happens. All right, so first of all, we are going to do our P's and Q's like we normally do. And then you can see here that we're going to need a not Q. And so we're going to do a not Q, and that it gives me false, true, false, true. Okay, now I want to do not Q implies P. Okay, so I'm going to look at this column, not Q, and I want to know what happens when it implies P. And so P is going to be, yeah, P is going to be the first one. All right, so we're going to do false implies true, true implies true, false implies false, and then true implies false. All right, so when we do that, you get true, 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 false. And this matches with what they said we should get. Okay, so that's how you prove that these definitions are true using a truth table. So if we get the same resulting column as it said that we should have in that table, then everything works out. So you're going to have a couple of these on your homework. So I just wanted to make sure I showed you how that worked. Okay. Now let's take a look at another example. All right, example 4. You have some problems that say translate the statement into symbols. So we have this statement here, neither smoking nor drinking is good for your health. Okay, so first of all, you're going to use that table that I told you was very important. Well, it's going to come in handy on all of these examples. So what you have to do is you have to start out by looking for key words. So in this statement, I had the keywords neither and nor. Well, if you go back and you look at that truth table, you actually have those keywords, neither P nor Q. So in this case, I'm going to say S, smoking is the statement, smoking is good for your health. And I'm going to let D be the statement, drinking is good for your health. And then I want to use symbols to translate this statement right here, that neither smoking nor drinking is good for your health. So in this case, I have a P and a Q. Well, I'm going to substitute those for S and D. All right, so that would actually look like that we would want to do not P or Q. Okay, so you see that in the red box, not P or Q. That's what we're going to want to make sure it looks like. So basically all you have to do is find the right truth statement that you're going to use and then substitute your variables in there for P and Q. So in other words, it was supposed to be not P or Q, and so I have P is the same thing as S, Q is the same thing as D. So my final answer is not S or D. I know that seems pretty simple, and it is, but at the same time, it can be confusing. So you might need to replay that and take a look at another one. But let's look at another example. All right, example number 5. Same thing, translate the statement into symbols. So this is actually a statement from a quote from Thomas Carlyle. No person who has once heartily and wholly laughed can be altogether bad. Okay, seems like a confusing thing. Well, I looked at these key words here and I said no and then can be. Then I went back to my table, and my table has this one section that says no P is Q. So I'm going to start looking at finding my P's and Q's. All right, so I'm going to say H is a person has once heartily laughed. Okay, then I'm going to let W be a person who has once wholly laughed. All right. So now that's my P and Q. So if I look at, oh, there's another one, B here, is a person is altogether bad. Okay. I have 3 statements here. And here's the thing. We have no P is Q. Well, the Q is the final thing. And so in this statement, the final thing is altogether bad. So Q is always a little bit easier for me to pick out. So I go ahead and name Q. Q in this case is going to be B. So I'm going to go ahead and say Q, you're assigned to B. All right. Now I'm going to look at P. In this case, I actually have a compound statement for P. And the reason I know that is because you have this word and. Okay, so since I have the word and, I know that P is actually going to be a compound statement that combines the once heartily and wholly laughed. Okay, so a person has once heartily laughed and a person who has wholeheartedly laughed, wholly laughed. And so I'm going to use that and to combine those. So in this case, I have H and W. So when I put all of these together in my sentence with the P implies not Q, then I have the P is going to be H and W implies not B. And that's going to be my symbolic statement. Okay, hopefully that made just a hair of sense. All right. Let's look at example number 6. Example number 6 brings the idea of tautologies back. It says to use the tautology And in this tautology, you see this double banded arrow. That means that these two statements, the P implies Q and the not P or Q, these are equivalent statements. So that's what that double banded arrow means, that they are equivalent. So, and according to this, this is a true statement. And it says to use this tautology to write the statement in equivalent form. So here's my statement. If the cherries have turned red, then they are ready to be picked. So P is going to be the cherries have turned red. Okay. Q is going to be they are ready to be picked. Now I need to do P implies Q. So there you have P implies Q. So now I want to write out the second part of the statement, not P or Q. All right, so not P. If the cherries have turned red is P, then not P would be the cherries have not turned red. Okay, so that's not P. Now I'm going to do or, then Q, and Q was they are ready to be picked. So my final answer here, this statement in equivalent form is the cherries have not turned red or they're ready to be picked. Okay, I'm almost starting to bore myself, so I just apologize for this. It just goes on and on. So, okay, let's look at another example. All right, now we're going to talk about negations. And you're going to have several different ways that they want you to write the negations. But basically, they're going to give you a compound statement. So in this case, you're given P implies not Q. And they want you to tell them the negation of that statement. Well, by definition, the negation of a statement, and this is a statement P implies Q, is equivalent to P and not Q. Okay, so these two things are equivalent. So if I want to negate this statement, I can turn it into P and not Q. All right, so let's substitute my values in. All right, so I actually want the negation of the statement that I got. And it turns out that Q in this case happened to be not Q. So I need it to be not Q. Okay, just let that sink in for a second. Not Q. Okay, well, if you are not Q, well, then you are just going to be Q. So it turns out that the negation of this set, when I negate it, by definition, it will be the same thing as P and Q. Okay, that's it. Okay, now let's take a look. I'm sorry, we have to do more examples. All right, let's look at another example. Example 8. We're going to write the negation of the compound statement, and this is a mathematical statement. 2x plus 3y equals 8 if x equals 1 and y equals 2. Okay, notice this one is a little different because it's kind of written backwards. So in other words, usually we see if something, then something, but they kind of just wrote this backwards. But it's still this x equals 1 and y equals 2. That's my P. And then this is going to be my Q, the 2x plus 3y equals 8. All right, so that is going to be my P. And then this other statement is going to be my Q. Now remember, by definition, to negate the statement P implies Q, then you would make it equivalent to P and not Q. All right, so let's go ahead and take our P. We're going to leave it just like it is, x equals 1 and y equals 2, and then we're going to join it with and not Q. Now, take a look at this. If this is Q, then not Q is basically going to say that 2x plus 3y does not equal 8. Okay, so the negation of this compound statement is x equals 1 and y equals 2, and 2x plus 3y does not equal to 8. Okay, hopefully you got that. I wish I could see you so that I could like see the deer in the headlights look, or maybe the light bulb go off, but I can't see you. So I'm just gonna, if you don't get it, just gotta replay it again or send me a message and say, I totally didn't get that. Okay. All right. Now, this is just a terrible question. In my book, it was question number 56, but it's all the way at the end of yours. And I just thought it was really ugly. And so I thought I would help you out a little bit with it. So let's just jump into it. Okay. To qualify for a loan of $200,000, an applicant must have a gross income of $72,000 if single, or $100,000 combined if married. It is also necessary to have assets of at least $50,000. Write these statements symbolically. Okay, that is just, it just sounds like tax law and banking stuff, and well, it's meant to give you a headache. So maybe you already have one, but okay, let's break it down. Let's take all of these statements. And in your homework, you'll have problems like this, and they will actually go ahead and list out all of the logical statements for you. So here they are. This is all of the statements that came with this problem. All right, so S, the applicant is single. Okay, and then they say if S is single, then assume that not S means the applicant is married. All right, A is going to be that the applicant has assets of $50,000. C is going to be a statement the applicant has a gross income of $72,000. D is the statement the applicant has a combined income with the spouse of $100,000. And Q is the applicant qualifies for a loan. Well, praise the Lord, they qualified for a loan. Well, we don't know if they did or not, but that to me is the easiest part, is that you want to get to your final thing, and the final decision in this is whether or not they qualify for the loan. So I typically always will start with the end and work my way back. Okay, so that's exactly what I did. Whatever is going to happen over here, it's going to be a lot of stuff over here, by the way. I know that it is going to imply Q. So I want to know what steps have to happen to imply that Q will happen. In other words, that the applicant qualifies for a loan. All right, now let's take a look at our problem. It turns out in this problem, we are going to have an or. And how did I know that? Well, we actually have two different cases here. We have a case of a set of circumstances if you are single, and then you have a set of circumstances if you are married. All right, so I'm going to be looking at that. I'm going to basically leave this space over here, and that's going to be for my single people. And then I'm going to have a set of conditions over here. That's going to be for my married people. And I'm joining them with an or because, well, you can't be single and married. That just doesn't work. So you're either single or married. So that's how I knew we joined it with an or. All right, so let's take a look at the single people first. So I have this single, and then I have and C and A. Now let's see how that works out. If you are single, in order to qualify for the loan, you have to be single, you have to have C, which is a gross income of 72,000. No. Yeah. The applicant has to have a gross income of 72,000 if you're single. That's what it says, if single. And then A, the applicant has assets of $50,000. So you have to be single, you have to have a gross income of 72,000, and you have to have assets of 50,000, and then you qualify for the loan. All right, now let's look at you married folks. All right, you married folks, remember, married just means that you're not single, and you have to have a combined income with your spouse of 100,000, and you also have to have that assets clause of $50,000. So here I have it broken down. These are my single conditions. These are my married conditions. If you meet either one of these situations, then you will qualify for the loan. Okay, now I'm going to write this out with some parentheses and some brackets. And I'm also going to rearrange these letters. Now, the S is going to have to come first, but this C and A can be interswapped. It doesn't really matter. And so I wanted to write my final answer a little differently. Same thing here. Not married comes first, but then these other two, the D and the A, they can be swapped as well. So it doesn't really matter. All right, so here's my final answer and what it looks like. I used a big set of brackets here because I wanted to make sure that you knew that one of these conditions over here has to be met in order for you to qualify for the loan. So that's why I used the big set of brackets. Now, each one of these, I have a set of parentheses. This is my single folks, and these are my married folks. All right, so that's how this would actually look. Now, in this problem, there is a second part to this problem where they're going to actually give you some information on a person, and they want you to tell them if they will qualify or not for the loan. So I'm going to leave that up to you and let you figure that one out. But hopefully, all of this will help you get through this section. I tried to pick a good range of problems that might be helpful. So just let me know if you have some other questions, and we will just go from there. Thanks a lot.